Hello my friends, so in this video I'm going to show you the power of running your ML algorithms on GPUs as opposed to CPUs. So as the title suggests, you can get some insane speed improvements. In my case, in this example, I got 137 times speed improvement using random forest. So basically what I'm going to use is a package called QML from Nvidia, which allows you to basically run sklearn like things, ML algorithms and that sort of thing, but on GPUs and not CPUs. So basically is like sklearn, but on GPUs. It's missing some features, but it has a lot, and when it works well. This is like a subset of Nvidia's like Rapids library. So Nvidia's Rapids library is basically a suite of things of like accelerators for data science libraries. So they have, let's say, QDF, which is like pandas on GPUs. QML, which is the topic of this video, is basically sklearn on GPUs. QPy is NumPy on GPUs. They have like QGraph, which is Network X on GPUs. They have like Dask type accelerators, which is like instead of multi-core, multi-processing on GPUs, on CPUs, they have it on GPUs. It works very well. When it works, it is missing some things, but when it works really well. In this particular video, I'm just going to give you a quick introduction on a random forest task with a pretty giant 5-second level data set for Nvidia, actually. Nvidia stock with like, let's say, like 30 or 40 technical analysis features, and show you the insane speed up. We're going to first do a version with Scikit-Learn, but I'm not going to run it all the way because it takes 3.5 hours. I'm going to show you how you can literally just change the from sklearn import whatever to from QML import whenever, and you get the insane speed up. So let's get started. Since the installation of this library takes a tiny bit of time, we'll do that first in this video, and then we'll go to the sklearn part to show you guys. So first, for runtime, you should change your runtime type to something with the GPU. So I chose this T4 GPU. So this is the QML part, and when you're doing a benchmark on timing, do not run two notebooks simultaneously because Google Colab might like do something with your resources. But just because we're just doing the install part in the meantime, it's okay. So like let's install QML. So you go to this link, and it gives you like installation guide. And the installation guide depends on like your version of CUDA, which is like the GPU like library. So how you can get what you need is you can do this command. You can do like Nvidia SMI, and you can run it. And once you get the answer, you'll see what version of CUDA you have. So you can choose like how to install. I know ahead of time that I'm usually getting CUDA 12. I once got CUDA 11, but CUDA 12, and pip is the package manager I want to use for Google Colab. Let's choose specific packages. So in this video, it just suffices to use QML, and let's just add QDF just in case. That's a data frame version, and we'll copy the command for installing. But as you see, when you run this Nvidia SMI thing, you get the CUDA version. So because you need to know if it's 12 or these 11 ones. Okay, so now you have the command, and to install, you just do the pip install, of course. So I'll do pip install this thing. So while this is running, let's do the whole Scikit-Learn part. It takes a few minutes. It's not that big of a deal. And then we'll show you just how easy it is to switch the Scikit-Learn part to the QML and get 137 times, in this case, faster results. Okay, so first thing we're gonna do is I have a pretty giant data set, 5-second data, not giant, but like about 3 gigabytes. So I'm gonna mount Google Drive. By the way, in this case, I have my runtime is like high RAM for both notebooks actually. So like, okay, I'm gonna mount Google Drive because my data is on Google Drive. Okay. And I'm gonna read to pandas. So this is stuff that's the same for the Scikit-Learn part and for the QML part. So Okay, one quick thing also is these algorithms. When you're using QML, you can either do it with a pandas data frame, a NumPy object, or a QDF data frame, or a QPy object. So it'll do the translations between GPU and CPU when needed. Okay, so now that I mounted the Google Drive, I can see like in my file system, if this will ever load, I see drive, and then the data set I have is called this thing. I want to use it's called DF Nvidia with features, because the point of this notebook is to illustrate the random forest performance improvement, not to illustrate the how to calculate the features. So like I'm assuming I have my labeled data set already. So let's do index call equals 0 equals date, and I'll do parse states. I can do parse states equals true, and I get my data frame. I'll just throw in a df.shape, which will give us the shape. Meanwhile, in the other notebook, we see the installation worked. Okay. So by the way, in the other notebook, we're going to do the same thing, mount from Google Drive, and read the exact same data frame. So I'll just copy this command. So this is the QML part. Sorry, oops. The QML part, same exact thing still. And I'm actually reading it into pandas here. Okay. Oops, sorry. It's a problem when your mouse doesn't work properly. So here, same as in the Scikit-Learn part, I mounted Google Drive, read to pandas. Nothing is different yet. Okay, so now in the sklearn part, we still don't have it loaded. So just a second. I'm switching in the meantime, so will be less idle time in this video. So we're doing the same thing. We're just loading our data set from the Google Drive into pandas data frame in both videos. Okay, so the sklearn part finished, and then we can do df.shape to get the shape of the data frame. We can also look at the data frame, of course. So let me actually do df.shape, and then I'll just show you how it looks like. So I basically have a bunch of technical analysis features, and I have a label at the end, which is 0 or 1, buy or sell. And it's every 5 seconds I have a point. So I'm just listing the feature columns here and the label column here. And so now I'll show you like a ML process. You will never ever want to split your data randomly into train or test when you're doing stock predictions or any time series for that matter. There's so much leakage and so much correlation between things, but this is just a computational performance video, so we don't really care about that. So let's just do something like, you know what, I'm actually not going to write this train size because in my other video, in my 137 time comparison, I didn't have that, so I want to keep it the same thing. But like, okay, you could do from sklearn.model selection import train test split. So we split our data into train test. Never ever do this for time series data, but this is just for comparison. So I can do xtrain.shape just to show you guys. I get this shape, and now I'm going to show you like the random forest. So from sklearn, random forest is like this. From sklearn.ensemble, import random forest classifier. We'll do n estimators as 100. We'll do max depth equals 8. And we'll do, there's a thing called max features. We'll do 1.0. That means, max features means like for every tree you randomly select, like let's say, like 30% of the features to build that tree for the random forest. So that's what max features is. You would never want to use 1.0 because that defeats the purpose of reducing correlation between trees. But this is, again, a performance video, so we're going to keep it like that. Also, I'll show you like an accuracy part. For let's do accuracy score because you can get the same thing. So here you fit the model, and then you get like an accuracy score. So I'll do like you fit the model in the training set, and then you get the accuracy score by doing like rf.predict x test, and then you get accuracy score, and then you can print the accuracy. So this is like the process of the random forest. There's other issues with random forest. Our data has so much serial correlation. We would never want to use, we would want to use this random forest with a lot of tweaks to fix that. But this is just a computational performance comparison video, so let's ignore that issue for now. So now we can put our random forest code in between like a timing block. So I can do something like import time, start time equals time.time to start, end time equals time.time, and then I'll calculate the elapsed time, which is the difference between the end and the start time. I'll just make it a little nicer because it's all in seconds. I'll convert it to hours, minutes, and seconds. And then I'll have an elapsed time, hours, minutes, and seconds, and we can run this thing. So remember, our data set was pretty big. So our training set is this. It's about 4 million, almost 5 million rows by 24 columns, and our whole data set was 6.5 million. So here it fits it on the training set, it makes predictions on the test set, gets the accuracy score, and you can wait 3.5 hours and you'll get your result. So let's go back actually now. Let's kill this because it does take 3.5 hours. And after, by the way, I show you can get feature importance. I make a note that like random forest classifier, by the way, is the most parallelizable algorithm in the world. Someone can run it from Dubai, from China, from Mexico, from the US, and then they can combine it at the end. It's super parallelizable. So in theory, if you have like, let's say 100 cores and you have 100 trees, you can just get roughly 100x if you have 100 cores. But let's ignore that for now. I'm just doing it as is with Scikit-Learn. So just bear that in mind. But anyways, this takes 3.5 hours with Scikit-Learn. So let's do runtime disconnect and delete runtime. And now I'm going to show you the exact same thing, but with QML. And as opposed to 3.5 hours, it will take a minute and a half on average for my tries. So just to show you, if I ran this all the way through, first of all, I got this thing. I got 3 hours, 25 minutes, and 1 second. Okay. So now the QML part, and we're going to do a lot of copying and pasting. So remember, we have our data frame as is, pandas like last time. I showed you guys, same exact process, rating to CSV. I define the feature columns and the label columns exact same as is. Randomly split the data, train test. This is where finally we have some difference because this will kind of make things into on the GPU already. So let me show you guys. So all I'm doing is, these are the functions I need. I need, sorry, we just ran this actually. So instead of doing from scklearn.model selection import train test split, we literally just change it to from qml.model selection import train test split. Literally the exact same thing. So look, I literally do this, and that's it. The exact same thing, no code changes. So now let me show you the actual building of the random forest. Okay, so to do that, we're going to literally copy this exact code, but we're going to change the QML part. See, this finished above, but now remember above what we had is we had, remember we had these imports, the sklearn ones. So now we're literally going to do the same imports, except instead of from sklearn.ensemble, we're just going to do from qml.ensemble and then from qml.metrics. So nothing except changing sklearn to QML. So now we can run this exact same thing, and instead of taking 3.5 hours, it'll take about a minute and a half, which is pretty cool. There are still some limitations. For example, like out of the box, you don't get Genie feature importances, but that's a very low computational effort. It's not like permutation feature importances. So that's one small thing. But like otherwise, like it's literally the exact same thing, which is pretty amazing, and it's running 137 times faster. We'll see the moment of truth because it's still a bit random when I'm running it here, if it'll take a minute 37, but we'll see. This is just my first video on basically accelerating these ML things with QML, and I'm gonna do videos on QDF and other things like that. So if you guys enjoy this type of video and you want more in-depth things, please like and subscribe. I'm gonna also show like more focused algo trading related things with this. So again, please like and subscribe and share is very important. And we'll wait for the moment of truth, how long it takes. It should take about 1.5 minutes, so hopefully it won't be here forever. One thing that does interest me while this is running is that I see that QML has examples with Shapley values and like feature and like visualizing feature importance. Wow, so 1.5 minutes or so, 1 minute and 41 seconds, that's amazing. Compared to 3.5 hours, which is insane. But of course, it doesn't come with everything out of the box, so like rf.importances, it's missing. But anyways, I hope you guys enjoyed this video. Please like and subscribe and enjoy the rest of your Sunday. Thank you.